Welcome to RCR Wireless News. I'm Martha DeGrasse, and this is the Tower Technology Trends webinar. I'd like to introduce you to your panelists for today. Al Burke is Assistant Vice President for RAN Hardware and Software Development at at&T. Al, thank you so much for being with us today.
Thank you for having me, Martha.
Aaron Blazer is Senior Partner at Atlantic ACM. He is our analyst today. Aaron, we're so glad you could join us.
Thank you for having me.
Marquis Doré is here. He is Fronthaul Product Line Manager at Expo, one of our sponsors today. Marquis, thank you very much for being here.
Thank you, Martha. Glad to be joining today.
And Lee Priest is here representing another sponsor, DTAC Systems, drone services provider. Lee, thank you very much for being here.
I appreciate the introduction, Martha, and look forward to talking more about drones later.
We do too. And I'm Martha DeGrasse, editor with RCR Wireless News. A quick word about RCR Wireless News. We are a premier news source for the wireless communications industry, a leading provider of carrier, network, device, test and measurement, telecom software, and IoT news. Find us at rcrwireless.com and at our newest website, industrialiot5g.com. Follow us on Twitter at RCR Wireless News. My Twitter is mdegrasse_RCR. Also find RCR TV on YouTube, where we have almost 7,000 videos at this time. Now, before we get into the discussion, I'd like to quickly call your attention to a report that published today on our website on Tower Technology Trends. You can find this report by clicking on the Reports tab at the top of the rcrwireless.com website. A few quick takeaways from this report. We were able to talk to several antenna vendors about current demand for tower top antennas, and we learned about the need for wide beam antennas that can support several spectrum bands as well as multi-port antennas. In addition to the sponsors that are here today, CommScope, Katrine, and Gamma News sponsored this report, and all three of those companies shared a lot of good information about antenna demand at this time. So if you're interested in that, I encourage you to check out the report. Other trends included fiber to the tower top and fiber testing. We hear so much about fiber to the tower top, but a lot of the efficiencies there are not completely realized unless the fiber is completely and precisely tested. So we cover that in the report as well. Also, the combination of fiber and cable in a single run. This is something that CommScope has pioneered, and the cable, of course, is still needed for power, so it's important. MIMO antennas are also covered in this report. At this time, 4x2 MIMO is rolling out a little bit. 4x4 MIMO is still waiting for devices. I think a lot of people are waiting to see if the next iPhone will be a 4x4 MIMO device, and that's really unknown because I think Apple recently announced that they would work with Intel on the next iPhone, so we'll see what happens there. Towers as hubs for small cells, another trend in this report. We hear so much about small cells, and I think it's important to remember that increasing demand for small cells can also mean new work at the tower sites, as a lot of that small cell traffic can be aggregated at a tower base station. Also, of course, the use of drones in the tower industry, which we're going to talk about quite a bit today. Drones used to look at sites before construction work is done and as well after construction work is done for closeout packages. We're also going to talk about some of the software that makes those drone photographs so valuable. And finally, the 600 megahertz spectrum opportunity. I think we've heard quite a bit this week about that, and possible delays there. So that's in the future, but it's still out there. Okay, so at this time, I'm going to turn the presentation over to our analyst, Aaron Blazer of Atlantic ACM. Aaron?
Martha, thank you for having me. Atlantic ACM is a Boston-based strategy consulting firm that advises operators, vendors, infrastructure owners, and investors on a wide range of business strategy topics. When we look at the industry and look at the evolution of the wireless space, we've historically seen a heavy amount of traffic growth over the last couple of years and really expect that traffic growth to continue. And with that traffic growth comes increased demand for network infrastructure. However, with what's happened from an end user service environment perspective, we're beginning to see a look for, and operators look for, more efficient means for deploying infrastructure from both a capital allocation and ongoing operating expense perspective, as operators need to maintain very high quality networks, but also need to hold their cost structure as we're seeing end user pricing under significant pressure. And what that's causing to have happen is operators undertake a multitude of strategies for both adding capacity as well as coverage to their network, and leveraging not just additional spectrum as they've historically done, or more macro sites, but leveraging new and emerging technologies to really improve the overall network experience. And with that, on the infrastructure front, on slide seven, we have our view on cell site growth from both a macro cell site growth focus versus non-macros. I think historically the investment in 2010 to 2015 has really been on increased macro sites with a heavy reliance on lit fiber for backhaul, migration from copper to lit fiber, and then also indoor coverage via DAS rollouts. On a go-forward basis from 2015 ongoing, we expect really the focus to be on non-macro densification. And with that, we're seeing three core areas of focus there, whether it be DAS, CRAN, or small cell. We bucketize all three as they're really being used to varying degrees among the different operators, and will evolve as network technologies evolve. And with that, we're also seeing the fiber backhaul side of things evolve to a dark fiber backhaul at macro sites, as operators are looking for ways to better control their cost structure from a backhaul perspective, as well as manage ongoing capacity needs. At the same time, when we look on a go-forward basis, you're seeing a heavy need and heavy growth in consumption of video and other forms of content over devices. And this is facilitating greater network capacity requirements, as well as changes in network topology. So we're expecting, with the evolution to CRAN and increased need for edge caching, we're seeing the emergence of edge data centers into the network on a go-forward basis as we look out into the future, with either BTS facilities or other data center facilities serving as interconnection points where content and eyeball networks can interconnect, similar to what we've seen in the evolution of the wireline networking ecosystem. So with that, we expect these operators to look for more efficiencies in their network, and also look for new technologies to really add that capacity requirement that they're going to have as usage continues to grow and evolve within the network.
Okay, great. Thank you. We're going to hear from one of those operators next, Al Burke from at&T.
Thank you, Martha. I've been involved with the industry for some 22 years, starting in the early days as a tower constructor myself, and things have changed drastically since then. I don't think anybody could have foreseen what would happen over the next 2 decades with, analog technology, 2G, 3G, 4G LTE, now 5G on the horizon. Has been very exciting, and the growth has just been very explosive, and it doesn't look like it's going to slow down anytime soon. Happy to be here today to participate in the discussion. Thank you.
We're glad to have you. Thank you. And at this time, we're going to hear from Marquis Ray of Exfo.
Thank you, Martha. So before we get started, I would like to introduce Exfo for those of you who are not familiar with who we are. Exfo has been in business for 31 years now. We're #1 in portable optical testing solution. And in fact, this is where we really got started. And along the way, we've provided, I would say, test and monitoring solutions to over 90% of the major CSPs, so the communication service providers around the world. Our expertise range from portable and lab test solutions for fiber, copper, communication protocols, in addition to service assurance and real-time network analytics. And one thing I must say is that at Exfo, we understand that our customers are going through major transformation. Customers like at&T, Verizon, Sprint, and whether it's modernizing their networks, such as deploying more fiber to the home, going through a cloud enablement process, like transforming their COs, their central offices, into data centers, or even going ahead to 5G and making sure that the right parameters are in place today. So Exfo is really there to help our partners. Next slide, Martha. So that's it. So before I go into a deep dive into this, the purpose of today's discussion is really to focus on next generation mobile fronthaul networks. And if we look at the evolution of the cell tower, in the past we had copper-based mobile installations where copper cables interconnected the base station equipment at the bottom of the tower to the antenna at the top. And I would say 2 of the biggest drawbacks from this type of installation is, first, a large amount of power loss in the copper cables themselves. So in some cases, we saw up to 50% or more of power loss in those copper cables. And to basically limit the power loss, the base station equipment needs to be very close to the antenna, so within a few hundred feet. And I would say that this type of legacy installation is very inflexible, given that the base station equipment and the antenna site needs to be co-located, so meaning that they need to be very close together. Now, today, what we're seeing is a new type of mobile installation, the RH, the remote read-ahead, which is composed of two parts, as you can see on the slide here. It's composed of the radio and the RF amplifier. And the RH is now placed at the top of the tower where it should be, very close to that antenna. And the BBU at the bottom is connected to the RH with fiber optic cables. So this is something that's fairly new. And with FTTA, or fiber to the antenna, the architecture virtually eliminates RF power loss, and compared to the legacy copper installation. And it really provides, in my opinion, tremendous power and cost savings for mobile operators. Next slide, Martha, please. So if we look at FTTA networks, which have become, I would say, common practice today, what we're seeing now is what I call the RAN evolution. We're seeing the second phase of the RAN evolution with CRAN, so centralized radio access networks. And in many parts of the world today, there's many types of CRAN architectures, and there's a lot that are being evaluated and many that are being deployed. And with CRAN and the fiber-based technologies, operators are really benefiting from centralizing those BBUs into a central office, a CO, or even a data center, and having the remote read-aheads, I would say, many kilometers away, up to, in some cases, 15 to 20 kilometers away. So it's really important to note that the centralization of the BBUs that you see here on the slide, it really provides or is basically essential for future 5G networks, because in the future with 5G networks, they will require ultra low latency communication between the BBUs. And while FTTA and CRAN provides many advantages, we're also seeing a new set of challenges when it comes to testing, validating fiber optic installations. What we've seen from our experience is that many in the mobile industry are pure RF experts, and many are not used to working with fiber. And fiber, we have to say, is a lot more fragile, and many precautions need to be taken during the installation phase. So based on our Exfo's experience during CRAN field trials that we did in many countries, we've seen that MNOs and the contractors are facing a lot of challenges on that side. And we're working closely with our customers and partners, such as at&T. And we've noticed that more of them want integrated and automated test solutions. And this is where our fronthaul test solution really addresses these issues. I would say that FTTA and CRAN networks are being built today as the foundation for what's coming next. So for what's coming in terms of 5G networks. Thanks.
Okay, thank you very much, Marquis. And now we're going to hear from Lee Priest of DTAC Systems.
Thank you, Arthur. And again, it's an honor to be here with the other guests on the webinar. Quick DTAC overview. We've been in business for 20 years in the wireless industry and primarily focused on installation and engineering services. And really today, the focus will be on the drone technology, which is kind of an outcropping of the engineering services. We've been primarily involved in audits for carriers and tower operators. And what you see here on the right-hand side is a drone, one of our customized drones. And what you're finding in the drone industry is you have a lot of technology today that is very low priced, and many of it's open system, and you can customize it quite easily. And that enables some very high megapixel photographs, some data that can be utilized in a form and fashion that it wasn't possible in years past by carriers. So even from a long distance from towers, we can get some very clear photos identifying serial numbers and other information that in the past just could not be done with cameras from the ground. Next slide, Martha. All right, in terms of our drone flight services, and I'll be brief here because we're going to get more into this later, but we're seeing quite a few environmental or bird nest studies today. I think everyone's very familiar with the challenge in the industry when there's a nest on a tower and it's during the migration period and work cannot be done if that nest is not verified as active or inactive. And it's something that can be done quite quickly with drones. In the past, you might have to send either a tower climber up, but there are risks in doing that. Some localities did not want someone to actually go up a tower and look at a nest in case there were recent hatchlings and there were disturbance to the nest. Also, it took time if someone had to sit by a tower for hours to see if there was any activity. And now, literally within minutes, you can drive to a tower and from a very safe distance determine if there's any activity. On the disaster side, we're not seeing much activity there yet, but the carriers and the tower operators are actually beginning to put together drone operators to have them on the bench in case there is a problem so they can get out quickly. One of the nice advantages of drones is you can actually do a live feed from the site to the customers. And we're also seeing general site audit. There's some pickup there, but where most of the activity is today, it's on the second bullet, which is post-installation inspections. So essentially, there is a carrier that, or a tower operator that doesn't install new equipment on a tower, and they want to verify that installation was done correctly. What you're finding is the cost using a drone versus a third-party tower climber to verify an inspection, it's roughly about half to 2/3. So it's a significant cost savings, and you can generally get a turnaround on that that's several days faster. And then finally, 3D modeling of towers. If you look at this picture on the right, it's actually not a photograph of a tower. That is a three-dimensional model that we created. And the way that that's created is you have a drone that rotates around the tower and takes hundreds, if not thousands of photos. And then we feed that into a software program and it develops this three-dimensional model. What's really a huge advantage here, it's not just for viewing. You can actually do extremely precise measurements of antennas, cables, whatever you'd like in there. And one element of this that's very exciting for the tower operators, if you click on any point on this tower in the model, the photos that created that point, so for example, if you click on the generator, the photos that created that point will pop up. So say 15 to 25 photos. So it now acts as a photo directory and allows folks to very quickly look at photos of any part of the site as opposed to going through a thumbnail database. And we have one tower operator that believes this could save each of their employees 1 to 2 hours a day in time.
That is significant. So we're going to, excuse me, we're going to look forward to hearing more about that, particularly some of the software a little bit later in the webinar. Lee, do you have anything else before we move on to the Q&A session?
No, all set. Thank you.
Okay, thank you very much. Very interesting stuff. At this time, we're going to start sort of at the top, literally, and talk a little bit about tower investment trends and tower valuations with Aaron, the analyst who is here today. Aaron, I know that we saw really high multiples in 2014, 2015, when the large tower companies, American Tower and Crown, bought the towers that the carriers had, the biggest carriers. And I'm wondering if you see those having come down a little bit and what you think is the outlook from here.
Yeah, I think the industry in some ways is shifting, but in some ways is at a lull. We saw a big boom in the 2012, 2013, 2014 time period of new builds and new requirements that really drove a lot of growth with very minimal, operator consolidation also. So when we look at multiples now, you saw the carrier portfolios sell for 20x plus tower cash flow, and you've seen some more recent deals probably in the higher teens. So you are seeing some shift there, but also it's an asset quality question. Are you buying a broadcast tower versus a operator tower versus a public safety driven tower? So there are a lot of different the composition of who's on the tower as well as the quality of the underlying asset does drive that valuation. So I would say there has been some come down, but I think we're also seeing investors kind of reboot for the next round here. As we think about all the spectrum that's been auctioned over the past couple of years and potential for more spectrum, the macro is not ultimately going away. I mean, if we look at our macro forecast, we're expecting 5 5,000 to 7,000 sites a year of new macros added, for the next 5 years. So there's still going to be macro demand, and macro is going to be that aggregation point. And the properties of a tower with multiple tenants and strong ongoing cash flow and escalators and all those great things that make the investment community love this asset are still there and aren't changing. So I think you may see some pressure in the near term. There may be people that have gotten over their skis or those sorts of things, but I think over the long term, right, the macro tower is still a very strong opportunity and strong investment. You're not going to see the rapid growth of 2-3 years ago, but there is still going to be a very solid profile there of the business on a go-forward basis.
So do you see private equity investors remaining interested in the tower sector as much as before, or do you see a lot of that interest shifting towards some of the small cell solutions?
So I think when we walk into and meet with private equity investors looking at the infrastructure space, there are 3 things that come up in every conversation: towers, fiber, and data centers.
Okay.
And really, it's been very hard outside of the macro tower environment. It's been very hard for investors to find scaled plays in the small cell world. Or, the one notable deal in the US, at least over the last 3 years, has been the Extenet deal with Digital Bridge. So you're not seeing scaled assets out there available. And that's really befuddled a lot of private equity investors. So I would say if they have their existing tower play and they're continuing to work on that tower play, we're not seeing a lot of new players come in to do tower deals. You are seeing some of the infrastructure related funds with different return profiles look at macro site tower opportunities, but you're not seeing much outside of macros with regard to cell site opportunities, just because of the lack of real scaled assets and potential for more technology risk or other shifts in the space.
Okay, good. And I know there are a few network operators that still own towers. Do you think that we'll continue to see that, or do you think that over time the tower companies will buy up almost all the towers?
Yeah, I think what you see left will be eventually spun out. I mean, we've seen the large deals done among all the large carriers. So there are smaller deals left to be done, but those, I think, over time will be done as the entity that owns them looks to monetize that asset ultimately. So, but we really, in the U.S. at least, seen the vast majority of deals done. I would say the carrier spinouts or sales are really more focused globally outside the U.S. at this point.
Right, that makes sense. Okay, Aaron, thank you very much. Okay, and now we're going to move on and talk about the main drivers of tower amendment activity. We are hearing that at this time there's more amendment activity than new site build activity in the macro sector. So Al, I'd like to start with you if we could and hear what you see as the main drivers of tower amendment activity now.
Sure, Martha. Over the last 8 years, between 2007 and 2015, at&T has seen data traffic grow on its network, on its wireless network, by 150,000%. That's with that kind of growth, it's facilitated, as was previously mentioned, lots of activity at the sites. The growth is going to continue, so there still be certainly some modifications necessary for that. Also, technological changes at times do require certain changes at the towers. That could facilitate some amendment changes. And there's also just the simple desire to potentially change the way a cell is operating and change the coverage pattern or something like that and modify the antennas that are on the site. That's a number of changes as well. So it looks like there's going to be a continued robust amount of activity with regard to modifications on sites.
That's great. And are you starting to see more MIMO antennas going up?
It's a little bit early to see that widespread, but that's certainly a part of the future of wireless, I would say.
Okay, great. Marquis, would you have anything to add about this?
Well, yeah, just as Al just mentioned, I mean, with the explosion of smartphones, if I remember correctly, in 2015 just alone, there was 1.4 billion smartphones sold worldwide. And for me, that's a crazy amount. So there's an explosion of these smartphones all around the world, and it's creating mobile bandwidth demands at an exponential rate. So on top of that demand, the mobile network operators such as at&T, Verizon, they're facing stiff competition between each other, and it's I think it's really forcing them to constantly upgrade and improve their mobile networks. And this is something that we're seeing as a test equipment manufacturer. And challenges for these operators is really to quickly and efficiently deploy cell sites or small cells to remain competitive.
Do you often see fiber to the tower as the reason for an upgrade, or something else motivated touching the tower and that fiber to the tower top was part of whatever else they were doing?
What we're seeing today, at least on our side, is there's many upgrades that are being done. So meaning that copper in some cases is being ripped out and replaced with fiber. And I would say that FTTA, or what we call CRAN, is really the biggest cost savers for mobile network operators. Just for instance, I would say two of the biggest operational costs for operators is power and a rental site location. So in that sense, with FTTA, with CRAN, they can reduce their power because they're going towards fiber, so no more copper cable loss. And also with CRAN, they can have, let's say, a remote site 15 kilometers away, a standalone remote site without the base station, and that, again, that saves on operational costs for operators.
Okay, all right, great. Now, one thing that we hear a lot about today is carrier aggregation, but I believe that that's not always actually a reason to add any new hardware to the tower. Aaron, would you agree with that? Aaron?
Yeah, when we look at carrier aggregation, right, in some cases you do see that driving simply software upgrades. So that, if you're just upgrading software within your network equipment, you're not driving any change to the tower ultimately, if you're able to make that nice and easy software tweak. In some cases, though, you may see tower shifts as well. It really depends on what the operator is doing and how they're making the shifts in their business.
Okay, all right, great. Thank you very much. All right, well, I'd like to focus a little bit on the fiber, although we have talked about that a little bit already. I think that, as you mentioned, Marquis, it is one of the biggest drivers of cost savings for the operators. And, it also does present some challenges. And I think, Lee, you have some insight on some of the challenges that operators face as they try to take fiber to the tower top and move those remote radio heads to the tower top.
Well, I think, probably my perspective on this, Martha, is what we're seeing in the field. The budgets are shifting significantly to the tower. So in the past, you saw, 5-7 years ago, a rough split in spend in the shelter and then on the tower. But I think, the group of folks on this call alluded to, everything's really moving on the tower. And that's, I think where the challenge is for the carriers is, there is an increase in need for high quality tower crews currently to install that equipment. And you're seeing a shift. A lot of companies that were more ground based are having to become more GC or construction oriented to meet the needs of the carriers. But I think you're seeing probably, in my opinion, 70% of the spend now is towards the tower, which is a significant change.
Okay. Marquis, I know that you've also noticed some of the shifts in the skill sets required of the workforce as operators work with fiber more. Is that right?
Yes, absolutely, Martha. So that's it. Exactly what you just mentioned is that the fact that optical fiber is, in some sense, new to the wireless industry, it does add a level of complexity during the installation and construction of mobile networks. If you look at the expertise in the mobile industry, most of the tower crew or the cell techs were used to working with sturdy copper cables, and now they're facing a set of new challenges with fiber optics, which is a lot more fragile. You got to be careful. You can't just drag it on the ground. It's got to be installed properly and well tested.
So what are some of the problems that you end up seeing when you do test these installations?
Yeah, good question, Martha. So for example, we recently worked with an operator. They were field trialing a CRAN network. And during this field trial, it was a small cell. So it was a CRAN architecture, a small cell. And that small cell was located 8 kilometers, so 5 miles away from the BBU hotel, which was located in a data center. And I would say that during that field trial, what we found was for sure many dirty fiber connectors with our fiber inspection probe, and that could totally degrade your optical signal. We also, what we found is we were able to pinpoint the exact location of missing fiber interconnections in the fiber span. So the fiber span was 8 kilometers. There was missing interconnections, and in this example, because it was multiple dark fiber spans, so there was maybe a fiber span of 2 kilometers, 3 kilometers, 1 kilometer. They were all interconnected, and there was some missing interconnections there. So because it's a new architecture, a new way of doing the mobile fronthaul, if you want, with our test solution, they were able to exactly pinpoint the exact location of those missing interconnections. And there's other examples there during that field trial. For example, the BBUs, the baseband units at the data center, we were able to test them with a test solution and verify if they were configured as expected. And some of them were not configured as expected. In other cases, we went to the remote site where the RH was located, and we found that they were not using the right remote read-ahead port. So in that case, there's in most cases today with the remote read-aheads, there's 2 optical ports. There's a primary and secondary, and sometimes they're not clearly labeled. So the contractors or the installers might install the SFP, the optical module that goes into the RH, and in that case, without a test solution or a test tool to verify that you're able to communicate or not with that remote read-ahead, it could cause a lot of headaches and increase the troubleshooting time in that sense.
Now, is the testing usually done while a technician is still on top of the tower?
Absolutely, Martha. I would say that's essential because as you know, tower climbs are fairly expensive. In some cases, we're talking between $2,000 and $5,000. So that's the most important thing, is that the testing is done while the tower crew is still at the top. So you would have a cell tech at the bottom with a test solution like Expos, and actually emulate the BBU at the bottom to be able to talk to that remote read-ahead at the top through the fiber span. So in that case, if it's not properly installed at the top, you have the technician still at the top, able to do the modifications to get that working. So if the technician comes back down and it hasn't been previously tested or verified, validated, well, in that case, somebody has to pay for that tower crew to go back up. Either it be the operator, the MNO, or it goes onto the back of the contractors. So absolutely, you need to validate while the tower crew is still at the top. Good question, Martha.
Okay, great. Now, Aaron, I'd like to get your perspective on the whole trend of the base stations being able to move away from the tower. And Marquise told us that it can be several kilometers away. And I know that you're following CRAN pretty closely. And I'd just like to get your perspective on what you're hearing from the different companies that you talk to about this trend.
Yeah, that's a good question. So I think the critical thing is we're very early in this trend. You know, if you look at what's happened within the U.S. wireless infrastructure world, it's really been the last 2 to 3 years where we've seen testing and deployments completed, or the initial testing and deployments completed. You know, we've seen Verizon be very early in this space with the heavily driven dark fiber strategy that really enables them to be aggressive in deploying CRAN. And initially, you know, we've seen the operators come with an outdoor DAS solution and then convert it to a CRAN type network. And that allows them to build that centralized point, have that fiber radiating from it, and then convert that network to a CRAN driven network. But CRAN's biggest complication and problems are making sure you have the fiber infrastructure really in the right places to hit your cell sites. So we're seeing a lot of new fiber infrastructure built to support these networks as they're deployed, and that is quite costly. So you have to allocate a significant amount of dollars in these deployments just to getting fiber infrastructure in the right places and really drive those deployments. So I think we're very early in understanding how heavy these CRAN deployments will be. Verizon really has been the clear leader in the US, but we do think you'll see other operators follow suit as they look to add density to their net density and coverage to their networks within major metro areas.
Do you see most of this investment in new fiber coming from the operators or from companies that are fiber specialized?
Yeah, so you have to look at it two ways. If you're an operator like Verizon or AT&T that owns a wireline network, within your ILEC footprint, you're going to try to leverage your own fiber to the best extent possible. And so you're going to spend internally or leverage your own internal plant. If you're an operator without a fiber footprint or one that doesn't own a wireline entity like T-Mobile or Sprint, a metro wireline entity like T-Mobile or Sprint, you're going to leverage outside providers. And that's going to create, we believe, significant new demand for networks built by people like Zayo, Light Tower, and other fiber-based operators out there that have dense metro fiber footprints. So we've seen Crown, for example, make significant investments in the fiber space with its acquisition of Synesis, as well as 3 other smaller acquisitions over the last 2 years. And really with that, Crown is looking to establish a beachhead within the outdoor densification market with the ability to enable small cells, outdoor DAS, and CRAN on a multi-tenant network. And the way you get that multi-tenant network is owning that fiber infrastructure.
Right, yeah, they call it the horizontal tower. Okay, the one thing we haven't talked about here is the way the fiber can reduce the energy costs. Marquis, would you like to comment on that?
Yeah, absolutely, Martha. So there's some studies that were done essentially on that. If you're going from legacy mobile installation, so the copper from the bottom to the top, to a FTTA, so fiber to the antenna or fiber to the tower, in that case, you potentially save up to 50% of the total on the electrical bill if you want. Moving towards a CRAN architecture, where the base stations can be centralized, let's say in a data center or in a central office, and the remote read-aheads are many kilometers away. In that case, you save an additional 10% on top of the 50% that's already saved just by centralizing those BBUs in the central location, where you basically save on your energy bill for, let's say, cooling, ventilation, and all that.
Okay, great. Thank you very much. All right, anything else on fiber and costs before we move on to talk about drones a little bit? Okay, great. Well, Lee, this is your area, and I'd like it if you could just sort of start off by giving us an overview. I think you already said that the post-installation was where you're actually seeing the most demand right now. Is that right?
It really is. There are some pre-installation inspections that are ongoing, but I think just when you look at the timing of the interest in drones with where we are in the year, the pre-install audits tend to happen in the beginning of the year or fourth quarter. So I think we'll see those pick up in fourth quarter and first quarter of 2017. But really, it's the post-installation, so it's essentially the closeouts or the third-party inspections after there's been an installation. And I think Marquis mentioned, and this is the real crux here, you know, it costs between $2,000 to $5,000 for a tower climb, just depending on what the scope is. And a drone flight is significantly lower than that. I mean, even providing a post-installation inspection coupled with a three-dimensional model is much lower than that $5,000. So I think that's where you're seeing the interest from carriers. There's a tremendous amount of pressure on them for continued cost savings. And this particular technology, you know, excuse the pun, it's really taken off in terms of not only gaining their interest, but helping them save a significant amount of money.
Absolutely. And Al, you, I think, have some experience with drones at AT&T. Is this what you're seeing?
Yes, you know, we're pretty excited about this drone technology here at AT&T. You know, we see this as a faster and safer way to do certain types of tower work. We first started investigating use of drones at our Foundry and Research and Development Center about a year ago, and we're starting up now a national program of drones to conduct cell site inspections. And we have done some inspections and plan to continue that. And AT&T also represents the telecom industry on the Micro Unmanned Aircraft Systems UAS Aviation Rulemaking Committee. So we think it's a great technology.
I'm sure you do. And can you evaluate, or can you comment on what you think is the most valuable as far as whether it's the site analysis or the ability to save fewer climbers from going on the sites? Where do you see the most value?
Sure. So inspection type climbs, as was earlier noted, where you need to inspect a site, but potentially after a storm where you're trying to ascertain the level of damage, what parts a later climber might need to carry with him. Disaster recovery, we think that's a future case where potentially even the drone could scout a way into the tower to see if the roads are safe from after a hurricane or whatever the case may be. So there's just a variety of use cases where we think that speed and safety can be enhanced with the use of these devices.
Okay, and what about the birds? We always hear about the birds. Are you using them to look at the nests?
I can't say for sure whether we've used that application yet, but that certainly would be an application, as we are under the same constraints as everybody else when it comes to the treatment of various forms of wildlife during construction.
Right, right. And I think that a lot of people may not be aware that just because there's a nest on a tower doesn't mean that it can be removed. There are a lot of regulations around that, right?
That's absolutely correct.
Okay, Lee, can you give us a little bit more information about the software that you use? I know we've had at least one audience question about that, and people are really curious about the CAD modeling software that you use when you collect these images.
Yeah, absolutely. So let me talk, I'll step back and talk about how it works. So when we take a drone up and we take a photo, the units are so sophisticated now, they actually can embed in that photo an exact location. And so we use our GPS system, that's the US system, and then also Russia has a system called GLONASS. Many times when we fly a drone, we'll have 12 to 15 satellites that are actually communicating with our drone. So we get a very precise location, we embed that in the photo, and then for each photo that's taken, it has that information. We feed that into the software program, and then that essentially stitches the photos together based on their locations and then the angles at which they're taken, and that develops the three-dimensional model, which, you know, I was mentioning the access roads a minute ago. What's nice about these models is, you know, the more photos you take and the different distances from the tower, you actually can create an entire model that includes the fall line of the tower, the access road, surrounding businesses, homes, you know, whatever it may be. So it's extremely useful. You know, in terms of the actual software that we use, I'm not going to go into that because we do use some off-the-shelf software that we customize. But there's a lot more capability today than there has been in the past to stitch these photos together and create models that not only can you measure with, and I mentioned that earlier, it can measure very accurately, you know, down to 2 centimeters, but it's also in color. There's another technology that's out there that it's been out for many years called LiDAR, and I don't find that to be as effective. It's very expensive, on the order in some cases of $50,000 to $100,000 per drone to add that to it. But this particular system that we use, it's called photogrammetry, the stitching together of photos, and it's extremely effective. I think it provides better information.
Okay, great. And I think you are also looking into robotics on drones so that the drones would actually touch the tower. Is that right?
That's right. You know, and it's interesting. This is a touchy subject with some folks, but our position is very clear, and that is we will take tower climbers off the towers. That's our goal, and we expect this to fully occur within 5 years. So we are adding, and other folks as well, it's not only our company, are adding robotics to drones. We're also looking at remote robots that can climb towers. They can use the safety climb as well as the pegs to get up towers, and they have other methods for climbing towers. And they'll be remotely controlled from the ground. So what we're going to see, I believe, over the next 5 years is a choice with tower climbers. They can choose to become certified to fly drones and to operate these devices from the ground. The nice thing about it is everyone wins. So from a safety perspective, you no longer have folks in the air. Also, these drones can deliver antennas and radios. They can actually pick those up and deliver them. The equipment's becoming lighter and lighter, so that makes things easier. But you will see the folks come off the tower and then doing things more virtually, using the equipment on the ground to control these remote devices.
And do you think there's an opportunity for some tower technicians to retrain as drone pilots?
Yeah, absolutely. What we found is that the FAA, when they initially launched the drone requirements, they were, very restrictive, and they have since lightened that up. I believe in August, the new regulations go into effect, which it's a much lower bar for someone to become certified to be a drone pilot. They don't actually have to have a pilot's license, which is currently the case. So absolutely, folks can transition into that role. And I think as you see more and more robotics added to the drones, and that technology improve, you'll see that the same folks begin to operate essentially robotic arms. They'll be on the ground and they'll be able to install and repair damaged equipment more terrestrial as opposed to in the air.
Okay, well that will be a big change. Does anyone else have anything on drones before we move on? Okay, all right, great. Finally, I think that we would like to talk about the 5G future. I know that nobody really knows what 5G is yet, although Verizon has a radio spec already. at&T, I'm sure, is hard at work and is part of the standards as well. And Al, I think you're the best person to comment on how 5G could ultimately impact the tower industry, in your opinion.
Sure. As you indicated, or somebody indicated already, it's still very early on 5G, but we do know it's going to be a highly dense, high throughput, relatively short distance technology, probably initially in the with fixed wireless and then moving later to mobility. There will be small cells a part of it, fiber builds as previously noted, alternative technologies, all that will be a part of 5G. There will, however, always be a need for a superior macro layer. So, to the extent that we see changes on the macro and the speed, I think, is still a chapter to be written. But I think, it is a technology that will require definite 5G type services, even when you're beyond these small, dense, high throughput areas that 5G will more focus in with its higher frequencies.
Okay, great, thank you. And what about testing, Marquis?
Yeah, well, maybe to add to what Al was just mentioning, one major factor driving development of 5G is the exponential growth of mobile bandwidth. And the expected performance objective for 5G, I gotta say, are really impressive. If that really materialized, in terms of peak data rate for 5G, they're talking about basically 100 times faster than 4G. So we're talking about 10 gigabits per second, as opposed to 100 megabits per second. And for sure, that is shared bandwidth to the users. And also, number of connected devices is supposed to increase by 1,000. So in a certain, let's say, in a square kilometer. So just to support all that, to support the massive amount of devices, there will be really a need to test and to validate. And on the fiber side, since the 5G objectives are so high in terms of bandwidth, the fiber bill on the fronthaul and on the backhaul will for sure continue to increase. Fronthaul protocol, let's say, carrying the digital RF, so carrying the signal between the BBU and the RH. We're expecting to see maybe CPRI rates going to 25 gig or even 50 gig. Or it may be something completely different than CPRI. CPRI is the protocol that's carrying the digital RF. And this is really creating some strains on eventually on the MNOs. So testing the network today to really build a solid foundation will be essential to the next step or the transition towards 5G. Okay,
thank you. And we hear a lot about spectrum, particularly millimeter wave spectrum for 5G. Aaron, I know we've got some spectrum auctions coming up over the next 5 years before we get 5G. How do you think 5G will impact spectrum valuations?
Yeah, I think that there's the core spectrum that's being used for providing the end user service, and then there's also what you alluded to with regard to millimeter wave potentially for backhaul. Verizon kind of made a pretty big splash with the acquisition of XO, really essentially buying optionality on spectrum to drive to potentially leverage for 5G and millimeter wave in that very high band spectrum, which really brought to life a spectrum band that kind of had been written off. The owners of it in the past that had tried to deploy networks over it, whether it had been Nextlink, which was owned by XO, or Fiber Tower or others, really had underperformed and had really failed to meet expectations from ability to leverage that spectrum. So I think you will see, if the 5G standard and if the network requirements involve that very, very, very high band, you will see significantly more interest in that, kind of the forgotten bands that were the Fiber Tower owned ex-Telco and the XXO spectrum. And then I think with the spectrum on the end user front, you know, we're continuing to see, there's the last auction still remains to be deployed, and then you have an existing auction out there now. And the operator's need for spectrum is not going away. They're definitely looking for more efficient ways to leverage current portfolios, but we don't see demand for spectrum and demand for capacity in networks slowing anytime soon, which all in breeds some pretty positive opportunities.
Okay, great. And Lee, I know you've already spoken pretty definitively about what you see happening to one part of the wireless workforce, the tower climbers. Do you have any further comments on how 5G technologies could impact the workforce?
Well, I think it only helps. You know, as we move really from the continuing build out of 4G into 5G. I mean, if it can essentially, you know, be on the back end of the 4G build out, it will keep that workforce in place and help avoid some of the peaks and troughs that we've seen with the workforce. In the past, it's been very difficult to build up a significant team and then, you know, 2 or 3 years later have to cut because the carriers just aren't building. So I think one of the wonderful things today about the improving technology, moving to 5G, is it keeps that workforce in place. You know, whether it be on towers or small cells, you know, it's certainly going to continue to help with employment.
Well, that's good news. Okay, well, we are running low on time, and we've had some great audience questions, a lot about drones, which we will try to work with Lee and maybe Al to get back to individually. We do have one question from Marquis about the optical link budget between the remote radio head and the baseband unit. Marquis, do you want to take that?
Yes, thanks, Bertha. Yeah, good question. I would say concerning optical link budget between BBU and RH, the optical link budget is really based on the optical SFPs that you're going to be using at the BBU and the RH. So when we're talking about 15 to 20 kilometers of distance between the BBU and RH, it does not come down to optical link budget. It comes down to latency. In the mobile communication, there's a process which needs to be done in a certain amount of time. So communication between the BBU and the end user, so at the cell phone. And that's really what is limiting that distance between the RH and the BBU today. So if in the future there's let's say better or faster processing BBUs, base stations, that distance will be increased. So today, in terms of optical link budget, it's not there's nothing limiting in terms of the optical side. It's really due to latency. So the longer you have the longer span that you have between the BBU and the RH, the more latency you will have. And as I said, communication between the BBU and the end user needs to be done within a certain amount of time. If not, you'll have drop calls, you'll have maybe glitches in the communication. So it's really based on latency and not optical budget. So optical budget, you could have 40-kilometer SFPs, it would work, but not in terms of latency.
Okay, great. Thank you very much. Well, we are running out of time, so I would like to thank all our panelists today. Al Burke, Assistant Vice President for RAN Hardware and Software Development at AT&T. Al, thank you very much. Your comments were really helpful today.
Thank you, Martha.
Aaron Blazer, Senior Partner at Atlantic ACM. Aaron, it's always great to have you on the webinars.
Thank you, Martha. It's always a pleasure.
Marquis DeRay at Expo, thank you very much for all the great information.
Thank you, Martha. It was great to be here.
And Lee Priest from ETAC. As we mentioned, we have a lot of questions for ETAC, and we will get those answered as best we can with Lee's help. Thank you for being here, Lee.
Thank you, Martha.
And I'm Martha DeGrasse with RCR Wireless News. Thank you so much for joining us, and this will conclude the webinar.